Okay, today we're going to go over section 7.2, which really pivots a little bit at first back into like a rational exponent section, but then it relates where radicals really come from, where the notation comes from, which is really it's just an exponent. The radical and the exponent or the radical is just a certain form of an exponent. Let me get this put in the right folder and then we can get going. Great. Okay, so let's go down to the desktop. I need to show you. Okay, so section 7.2 is on rational exponents. If you're following in the book, it starts on page 519. And the first thing your book goes over really is connecting the root and the rational exponents. So it turns out, and I'm going to write this kind of backwards because it's where we started yesterday. If we've got the nth root of a, so whatever n is, it could be the square root, the cube root, fourth root, whatever, the nth root of a actually equals a raised to the 1 over n. Okay, so there's the connection. So there's the connection. So if we wanted to write something in exponential form and radical form, here's our, kind of pathway to both, okay? And that's exactly what your book starts with. Your book first starts with, writing writing exponent in a radical form. And then I'm going to do kind of vice versa. So let's say we had exponent, let's do radical form here. An exponent form here. So radical form and exponent form, we're going to go back and forth. So if we had something, let's say in exponent form, let's say we had, x to the 1/2 power, something kind of basic. If this was an exponent form, if I wanted to write it in radical form, well, look, the denominator of this fractional exponent, that's called a rational exponent, rational means fraction, is 2. So therefore, this is just the square root of x. Pretty straightforward. Okay, the square root of x. So if we had something, let's change it up. Let's say we had the fourth root of 2, which we can't simplify. The fourth root of 2 we can't simplify. 2 is a prime number. It doesn't break down in that factor tree. But all I want to do is write it as an exponent. So this would be 2 raised to the 1/4 power. Pretty straightforward. Okay. So we've got to be careful with what's actually being raised to the power. So if we had something like, let's say 2x to the 1/3, 2x to the 1/3. Now look, be careful. They're trying to trick you here. This 2 is not being raised to the 1/3. 2 is really just raised to the first power here, right? If we wanted it all raised to the 1/3, we would need parentheses. So 2x raised to the 1/3, if I wanted to write that in radical form, the 2 is a coefficient. And the cube root actually just goes on the x power. So the 2 is really only raised to the first power. It's not raised to the 1/3. So if we wanted the entire thing simplified or rooted, I should say, we would need a parentheses. Like if we had 5, let's say y to the 1/5 power, right? 5y to the 1/5. Well, this is all raised to the 1/5 power. So it's all going to go under the root. So this would be the 5th root of y. Okay. Same issue with negatives. Let's keep going here. So we've got radical. I'll just do a few more examples. Radical and exponent. We've got to be careful with negatives, right? Because we know negative roots underneath we can't do. So this one will probably simplify out. So if we had something in an exponent form, let's say -9 to the 1/2. Well, -9 to the 1/2. Again, that negative is not being raised to the 1/2 power. That the 9 is the only thing being raised to the 1/2 power. If I was going to write this as a radical, it would be negative square root of 9, which just winds up to be -3. Okay, just winds up being -3. If we wanted that negative to be raised to the 1/2, just like down here, we would need parentheses. So negative 9 raised to the 1/2. Now we know this would wind up being the square root of negative 9, which for us is just non-real at this point. Again, we're going to talk more about that in section 7.7. Okay. So that's just going back from the radical and the exponent. Whenever the exponent is just a fraction, with really the numerator is 1, we're going to get, well, what happens when the numerator is not 1? We'll deal with that here in a second. But this is just going back and forth. Maybe I'll do a few examples that your homework throws out there to show you. Use radical. Okay, yeah. So your homework on page 524 brings up a few examples where they're just saying, hey, use radical notation to rewrite the expression and then simplify if possible. Okay. So let's see here. This paper underneath there. I'm going to steal one here. Let's say we've got, this is number 6. Number 6 says 1/64 to the 1/2. So if I want to write this as a radical, it's going to be the square root of 1/64. And yesterday we talked about the radical of a fraction. You've got to take the root of the top and the bottom, right? The square root of 1 over the square root of 64. Now, the square root of 1 is just 1. I'm not going to go through the whole rigmarole like I did yesterday about simplifying square roots of numbers. You can just pop this in the calculator. 7.3, we're going to go back over the that factor tree and just more in depth. So in 7.2, though, pop that in your calculator, you wind up with just 8. Okay, you wind up with just 8. Number 6, let's do another one. Okay, yeah, let's do number 12. Number 12 says 16 x to the 8 raised to the 1/2 power. So 16 x to the 8. You try this one. Try this one for a minute. See if we can get it. Okay, so if I was going to work this one, it's the square root, right? Because there's a 2 under there. 16x to the 8. And remember, we can take the square root of both of these, right? The square root of 16 is just 4. The square root of x to the 8th, remember I have to say how many times does 2 go into 8? Because it's an exponent. So it's x to the 4th power. So 4x to the 4th power. Okay. We'll stop. Yeah, we'll stop there because we'll come back and do more examples. I'll even use this, save this paper for later to come back and do some more examples. Okay, so let's go to the next topic, what happens if you don't have a number in the numerator of that fraction? Well, there's 2 things that can happen. So if we have, let's say, some value raised to the m over n, you can either bring that m inside the radical or leave it outside. So if you bring it inside, it would look like this. Right? The m can be raised to the a on the inside. Now, that n is still the root no matter what, okay? Or you could write it like this, the nth root of a, and then raise it to the m power. Either one is fine. It doesn't matter. They're the exact same thing, actually. Sometimes students like doing this version more, or I feel like students have said they like that version more because it makes the number smaller if a is a number. Let's say, I'll give you an example. Let's say we had 9 raised to the 3/2, okay? If we work it this way, the second way, it will be the square root of 9, and then you cube it, okay? And notice the square root of 9 we know is 3, right? Square root of 9 is 3. And then you raise it to the 3rd power. Well, 3 times 3 times 3 is just 27. So if you do it the other way, you would actually cube 9, 9 cubed, which I'm not sure what it is. It's a really big number. And then you would take the square root of it. So it just takes a little longer by doing it with this first method. The second method is nice when you have numbers going on, okay? The second way is just nice when you have numbers, and you'll see me do more of the second way in this class. Now let's look at another example of this one. Let's say we had, okay, yeah. This is just an example in your book. Negative 16 raised to the 3/4 power. Well, again, that negative is not being raised to the 3/4 power. So I'm going to go to this equality here. So this will be negative. Now the root is 4. 16. Now look, the negative is not going to be raised to this third power. That negative is on the outside. It is not. It's really like saying -1 times 16 to the 3/4 power. Okay, and you just focus on the 16 to the 3/4, which is right there. Okay, so I've got to find the 4th root of 16, and if you're like, man, I have no idea how to do that, well, we can use a little factor tree over here. 16 is what? 8 times 2, 4 times 2, and 2 times 2. Notice there's 4 2's. We're taking the 4th root. Oh, let me write this underneath here. Lower. So therefore, we wind up with the 4th root of 16 just being 2. Okay, and then you've got a cube 2. Well, 2 times 2 times 2 is just 8. So you wind up with -8. Kind of neat. Okay, you wind up with -8. Okay. Oh yeah, don't let the binomial stuff fool you. I don't know why they throw this out there, but like 4x minus 1, I'm stealing this straight from the homework example. Raised to the 3/5. Look, that 3/5 cannot be distributed inside that binomial because there's addition and subtraction. Or that for this example, there's subtraction, right? There's subtraction going on. So we can't distribute the 3/4. All we have to do is just write this as a radical. So we're going to say the 5th root of, now they write the cube on this one on the inside because we're not going to do anything, okay? And they just leave it. Okay. Questions, comments, concerns before I keep rocking and rolling? Okay. The next few parts of this section really turn into a review of exponents, which we went over. I thought it wasn't the last test, was it? I think it was the test before. I might have been 3 tests ago, man. This semester's really going. But it just turns into a review of how to simplify exponents. So hold on, I'll pull this one out. So let's say we had, I'm going to steal it from the homework. Homework number, yeah, like number 30 here. We've got 64 to the -2/3, right? 64 to the -2/3. Well, we've got to remember how to deal with negative exponents, right? Negative exponents, if you go back to that simplifying exponent section, the negative exponent, you would always put in the denominator and it would turn positive. So we're going to pop this in the denominator. And notice it turns positive. And now I can do what I've been doing in this section. So the negative exponent, remember, you put it in the denominator, it's positive. Then we wind up with 64. Ooh, here, write this because it's a cube root, right? Cube root? Did I write this down right? Yeah, okay. Cube root of 64, and then we're going to square it. Okay, so I've got to find the cube root of 64. So let's put that up here. So 64. Ooh, let's see here. We know it's 8 and 8, right? Start there. Now look, I'm going to be a little lazy. I know 8 is 2 times 2 times 2. We've talked about this already. Okay, but for this one, we need to find the cube root. So we've got to get 3 of a kind. Let's see if I can, and we can see the 3 of a kind there. I'm going to steal another color marker, the purple one. So I've got 3 2's here, and I've got 3 2's here, right? So therefore, the fourth root, or I'm sorry, not the fourth root, about to be 4. The cube root of 64 would be 2 times 2. So the cube root of 64 winds up just being 4. Okay, you can pop that in your calculator and get it as well. But the cube root of 64 is just 4 because it's 2 times 2, right? 3 of a kind 2s, 3 of a kind 2s, and you multiply them together, you get the 4. So now we have to square it. So 1 over 16. Woo! This wound up being a lot of simplifying. Now I goofed up here, right? But this had quite a few steps going on. Quite a few steps going on. Okay. Find another one. Okay, let's look at 34. 34 looks similar. It says negative 16. Now it's got parentheses, so the whole thing's going to be raised to whatever we put up here. Negative 16 to the negative 5/4. Okay, so let's see. First, I've got to make this negative go away by putting the entire thing in the denominator. Right? Oh, wait, that's a negative 16. So now I'm going to write this in radical form. So it would be 1 over the 4th root of negative 16 raised to the 5th power. So 1 over the 4th root of negative 16 raised to the 5th power. Well, turns out can't do this, right? We've got an even root and a negative underneath the radical, negative radicand. So for now, we're going to call this non-real. And why is it non-real? Even root, negative radicand, non-real number. And actually, that's what your book says, not a real number. Okay, non-real number. Awesome. Okay, let me steal another one. And the other ones are really just, okay, so they do a little section. If you look in your homework, like 29 through 39, it's just a section of write with positive exponents. So they don't even really want you to get it in radical form. They're just writing with positive exponents. It's genuinely a remember how to simplify this stuff. Like if you looked at 40, it says 2 over 3y to the negative 5/7. Like they're not asking you to make this into a radical. They just want you to remember how to simplify it. So all we have to do is put this in the numerator, 2y to the 5/7 over 3, and we're done. Okay, and that one we didn't have to write it in radical form. But if we looked at, like, let's see here, the next section, use the properties of exponents to simplify each expression, write with positive exponents. Okay, so still it's they're not asking you to put in radical form for like 41 through 59. They're not asking you to put in radical form either. So if we looked at, let's say, 44, you've got y to the 4/3 times y to the negative 1/3. Oh, okay. Remember, when you multiply the same base, you add the exponents. 4/3 plus negative 1/3. Hey, that's nice to have the same denominator, so we can just add them together. So we wind up with 4 plus a negative 1, so that's 3 over 3. So we just wind up with y, really y to the 1, right? Y to the 1 power. Okay, let's look at 48. 48 says x to the 3/4 over x to the 1/8, right? So in this one, we know, we've got the same denominator, or same base, so we have to subtract the exponent. So this winds up being really x to the 3/4 minus 1/8. Now we don't have a common denominator here. The common denominator between 4 and 8 is 8, right? You got to multiply this fraction by 2 on top and bottom. So you wind up with x raised to the 6/8 minus 1/8. So you wind up with x to the 5/8. X to the 5/8. 48. Let's try those last ones. Okay, so let's do now the last part in this section. This isn't a long section today, guys. It's not gonna be a long lecture. But the last part actually is going to be using rational exponents to simplify. And it's really 61 through 85 in the homework. And let's look at this. I'm going to do this based on an example. So for the first one, let's say we had, this is number 62. We've got the 9th root of a cubed. Now look, if we wanted to simplify this from the last section, remember you have to say how many times does 9 go into 3? Well, 9 doesn't go into 3, right? But the question asks, use rational exponents to simplify each radical, assume all variables are positive, and then you can look back and see the examples these go with. Well, what they want you to do here is actually write this as an exponent. So if I wrote this as an exponent, remember the 9 is the denominator, the 3 is the numerator. So 3 ninths. Well, 3 ninths simplifies, right? 3 ninths simplifies into 1/3. And then they want us to go back into radical form. Okay, they want us to answer this in radical form. Well, a to the 1/3 is just the cube root of a. So they're considering this simplified, going from the 9th root of a cubed to the 3rd root of a, the cube root of a. Okay, so that's what they're wanting. And we'll dig into some more in-depth ones, but that's what they're wanting us to do. So like if we looked at, let's look at 70. 70's got the 9th root of y to the 6th z cubed. So again, they want us to write this as an exponent. So it's going to be, okay, let's think about this. This would be y to the 6th z cubed raised to the 1/9, right? Because it has two variables, I'm going to just raise it to the 1/9 first and then distribute it through. So you get y to the 6/9 times z to the 3/9, right? Hey, we know what 3/9 simplifies into. It's 1/3 from earlier. But 6/9, they're both divisible by 3, so that winds up being 2/3. And this winds up being 1/3, okay? So y to the 2/3 times z to the 1/3. Now what's important here is both of these have the same denominator, right? They both have the same denominator. So if I wanted to write separate radicals here, it would look like the cube root of y squared, right, for this first one, times the cube root of just, oh, crap, that's a z, okay? The cube root of a z for the second one. And because they have the same root, you can combine them. Y squared z. Now look, there's other ways to simplify this one. There might even be a more simple way to simplify this one. But that's where my brain went. Okay, so first we made the root an exponent, so 1/9, distribute it through, and then simplify each fraction out. Then make each fraction a root and then combine it. Okay, that's just one way to do it. There's probably many ways to do this example. Okay, so let's keep going with these. I guess they become more complex here at the last few. So if we looked at 75 here, 75's got the cube root of b squared over the 4th root of b. Okay, so what we'll do here is we're going to make both of these into exponents. So this is going to be b to the 2/3 over b to the 1/4, right? So we're going to make both of those fractions, fractional exponents. Oop. So put, and then we're going to subtract 2/3 minus 1/4. Right now, look, if you're like, man, I don't remember how to do 2/3 of minus 1/4. The common denominator is 12, right? So we're going to multiply the top and bottom here by 4 and the top and bottom here by 3. So we wind up with 8/12 minus 3/12. So this winds up being 8 minus 3 is what, 5/12. So if I subtract 2/3 minus 1/4, I wind up with 5/12. Okay, I wind up with 5/12, b to the 5/12. Pretty straightforward. Okay. Oh man, let's do one here at the end. These are pretty cool. Nice challenge. This is 84. Ooh. '84 says the fourth root of 5 times the cube root of x. Okay, the goal here is to use rational expressions to write as a single radical expression. Okay, so we're going to use, look, we can't combine these because we've got different radicals going on, right? But we want to combine them into one radical. So we're going to manipulate them into one radical. So again, I'm going to write these as a single, or as exponential rational exponents. Gosh, that's the word I was going for. Let's think. We've got 5 to the 1/4 times x to the 1/3. And look, we could combine these. Ooh, my back's hurting. We could combine these if we had the same denominator. Okay, if we had the same denominator, we could put them under the same root, right? Right now, they don't have the same denominator. They have a 4 and a 3. But if we found a common denominator between 4 and 3, we could actually create this single radical. So to do that in this first, well, 4 and 3, just like the last question, the common denominator for 4 and 3 is just 12. So I'm going to multiply this one by 3 on top and bottom, and this one by 4 on top and bottom. So I wind up with 5 to the 3/12 times x to the 4/12. Okay. So now here, what I need is both of these 12th roots written out front. Okay, so I'm not going to worry about the exponent. That's just going to come into the base. So I'm going to write these as radicals. So I'm going to say the 12th root of 5 cubed, right? We can do that, times the 12th root of x to the 4th. And boom, there we go. We've got the same root. We can put them underneath the same radical. The 12th root. Now 5 cubed is 125. I'm going to just write it out as 125. X to the 4. Pretty neat stuff. Okay. So the 12th root of 125 x to the 4th. Okay. So this is it for this section. The homework, I mean, it's not long. You got 30-minute lecture. The homework starts on page, it's for 7.2, starts on page 524. And it goes from 1 through, let's see here. Yeah, you could do 1 through 85, and you could do every other odd if you wanted, honestly. And then if that's not enough, if you feel like you don't really have it yet, then just do every odd. But I would suggest doing every other odd, 1 through 85. And then if you need extra help, do every odd, because there's enough homework in this section where you'll hit all the different types. Okay.